I'm Paul Griefson, and I'm a senior technical artist at Embark Studios, working on the finals and our creators. Welcome to my presentation on tools, services, and an information ecosystem. I hope that by the end of this talk, you will understand what I mean when I say the whole is greater than the sum of its parts. So, here's what we're going to look at today. Firstly, why making games is complicated, and how we can simplify that as much as possible. Then we'll take a look at some specific examples of tools that we've created at Embark to help us work more efficiently. At the end, I'll cover a bit about how we can use large language models, or LLMs, to help us in other ways in the future. So, as you are all likely aware, making games, especially large systemic games with big teams, is complicated. Why is that? Well, with big projects and big teams, we have many moving parts. There are different departments, different teams. Each one may have a large amount of developers, and it means that communication and sharing becomes really important. But each team often has its own ways of working and their own preferred tools, so communicating clearly and consistently can be difficult. I think that any really good project needs to have a vision that is shared by the whole team, and to achieve that, you should strive for a single source of truth. You need to avoid outdated information and contradictory messages, and make sure that people have an easy way to find whatever they need. So, to give an example from Embark, these are things that we consider as sources of truth in our information ecosystem. We have documentation stored in tools like Notion, Google Drive, Miro. Then we also have tasks and planning. For us, this is usually Jira, but it could also be in Miro or Notion for higher level plans. Obviously, we need game data, which is stored in version control, such as Perforce and Git, along with databases of online data. Another piece of the puzzle is what happens with discussion and feedback. We have meetings with notes in Notion. We have Slack discussions. There are surveys, analytics we can use to gather more specific metrics and trends. There's obviously a lot going on here, and there are many ways for things to get lost, stale, forgotten, or miscommunicated. It's becoming obvious that it's not really possible to have a single source of truth, but what can we do to help keep things clear, fresh, and well-connected? So, firstly, there's the obvious stuff, cross-linking and embedding information. For example, embedding Miro boards, Google Drive files in Notion, or having documentation links from inside Unreal. This is very easy. There's no reason for anyone not to do this. At Embark, we value the whole team's contributions, so we have simple public Slack channels where anyone can provide suggestions and feedback on our games and tools. We can also use surveys, both in-game and externally, to gather more data from the development team and the players. Something we also strive for is simple, clear, and powerful APIs that any developer can use, since this allows us to build connections internally with minimal overhead. I'll provide some specific examples of this later. Finally, I'd like to mention sharing links via URL handlers such as Skyhook. This is a tool we use every day at Embark that allows us to copy deep links to any assets inside Unreal or any other software throughout all of our software. This makes it easier for developers to ensure that they're looking at the right files in the right location. One thing that I think is fairly important when it comes to information ecosystems is that you should avoid reinventing the wheel. Standardizing the tools that you use as much as possible will help reduce complexity and make it easier to share. Reuse and improve existing solutions instead of trying to make something new that fulfills the same purpose. Sometimes this requires being more strict with how people should do things via sharing and education, such as code reviews. If someone wants to introduce a new tool or source of truth into the ecosystem, be very thorough in verifying that it's actually adding something unique and not duplicating existing functionality. Also, especially with larger teams and big engines such as Unreal, It's easy to overlook existing systems that fulfill your requirements. I find it's often worth spending a bit more time upfront doing research into existing solutions instead of jumping in to write something new just because you didn't spend time checking what was already available. With all of that in mind, let's take a look at some specific examples of tools that we use at Embark to improve how we communicate and share as a team. Let's look at reporting and tracking bugs, issues, and feedback in the game. It's something we do all day, and every studio probably has their own solution for this. At Embark, we call our solution Spot. Spot provides a very easy-to-use way for any developer to report an issue from inside the editor or the game, and provides a lot of useful metadata to help reproduce the issue. Once someone has made a Spot report, it automatically gets posted to Slack. From there, we can easily convert it to a Jira issue if we need to. Finally, we can display any reported issue in Unreal Editor at the location where the issue was reported. So here is what it looks like. This is what it's being used to report minor visual bugs in Arc Raiders. You can, as soon as you see an issue or want to provide feedback, they just hit a hotkey to activate Spot. This captures a screenshot, and they can immediately start typing to create a description of the issue, paint on screen, or highlight areas. They can double-click on things in the view to add deep links to those assets, such as blueprint classes or static meshes. And once they've done this, they just click the Submit button or hit Enter to choose the most appropriate type of report, and finally submit it. And Spot automatically provides as much context as possible, the level name, server ID, lighting conditions, locale, and whatever else we think is important. And this is all customizable per project. So here's how Spot has evolved over the past year or two from initial implementation to where it is now. Ivar Dahlberg, who is a technical art wizard, implemented the first version entirely in Blueprint, and this was immediately useful and fully functional, and the team loved the simplicity of using it. However, due to being implemented in Blueprint, it's quite hard to maintain and evolve as a tool, since it was built with monolithic Blueprint assets. It was not so easy to merge or extend. So later, Ivar and I ported it to AngelScript, which we use as a scripting language for Unreal. This allowed for much faster iteration time and more parallel development, so it became easier to maintain and extend. Finally, the goal is to move it to a fully standalone C++ plugin, since this will give us the best performance and have no complex dependencies, but still allow customization and modularity on a per-project basis. The important thing here is that Spot has always been useful, even from the very first implementation. This is some example of the customization settings for Spot. Since it is a studio-wide tool at Embark, we expose some simple and clear options to tailor it to every project's needs. This includes a default Slack channel for the project, and then a list of sentiments, which define the types of report you can send, and finally, where the files will be uploaded. Each sentiment can have a custom icon and tooltip, and can override the project's default Slack channel if needed. For example, localization issues get sent to a separate Slack channel than art and design issues. Extending Spot to add arbitrary metadata is very easy. We gather all non-abstract subclasses of uSpot metadata collector. Good luck with that, translators. And iterate through all of them whenever we take a Spot capture. This gathers all the metadata keys and values, which are just strings for simplicity. In AngelScript, all methods are virtual by default, so these are all overridable in subclasses. This gives us a very simple and clear API that anyone can use. Here's an example of a shared metadata collector that works for all the projects. It gathers the language and the locale that the user was playing in, useful for diagnosing localization issues. This is a very simple class, just overrides 2 methods and returns some strings. And here is a project-specific metadata gatherer, which just gives us the currently loaded lighting and weather scenario on Arc Raiders. The project codename is Pioneer, which is why the class and function names are called Pioneer. Again, this is very simple, just overrides 2 methods and returns some strings. So it can take less than a minute to write a new metadata collector for Spot, and no other work is required since Spot gathers all of these at runtime. So what happens after a Spot report is sent from Unreal? We upload the captured screenshot and associated JSON metadata to a shared network location. We then have a small Python service which watches the network location, sends any new reports to the appropriate Slack channel based on the metadata. Once the report is in Slack, then developers can choose to convert the post to a Jira issue if they wish. So this is what it looks like in our Slack channel. Here is a Spot report with some floating grass that someone posted in the ArcRaiders channel. So we use a third-party Slack integration called Trooper, which allows us to create Jira issues based on a simple emoji reaction to any Slack post. It's very handy. Different emojis correspond to different types of issue. So this workflow is mostly driven by QA and the art team, but anyone can use it, and it's very easy to customize. And since it is just a generally applicable Slack extension, we can use that anywhere else in Slack as well for ease of creating Jira issues. Here is my favorite outcome of using Spot. Because we have all the metadata, we know exactly which map and location the issue was reported from. So we can use this to display the issue directly in the Unreal Editor viewport. This video shows the spaceport map from ArcRaiders with all the issues that have been reported from Spot. A developer can just click on the issue, and the tool will jump to the exact location that the report was sent from. You can then just look around to see if there are any other issues that might need to be fixed in the same area. Developers can sort and filter issues to quickly find the tasks or bugs relevant to them. And this greatly increases the speed at which a single developer can find and fix many issues. There's no need for web browsers, no other out-of-context applications that make you leave Unreal. Nice. So this approach reduces turnaround time between reporting and fixing issues. There's less production overhead, as developers can take issues as they see them, instead of needing to be assigned out to them. It also allows for more developer ownership, which I believe allows people to take pride in their work and increases the quality of the game. So what else can we do for faster turnaround time and less production overhead? Since the games that we make at Embark are online multiplayer games, we need an easy way of updating live data without needing to make an entirely new build of the game. The process we use to facilitate this is called web export. It takes all of the items in our Unreal games as a single source of truth and exports them to JSON format to be ingested in our live games database. We then have a Game Tools website, which allows any developer to browse, edit, and update this live data as they wish. We also allow deep linking back to Unreal to make it easier for developers to find the source content. And similar to how we saw with Spot, the web export system has a very simple structure based on just gathering non-abstract subclasses. This is a very common pattern in Unreal, which makes it easy to extend and write new web export setups for new asset types. You can just implement a new web export collector subclass, supply properties that you want to collect from any assets, and this is automatically written out to JSON along with all other web export packages. Web exporters can also export Unreal texture assets, such as PNG image files, which is useful for icons or previews of items. And the actual web export process just runs as an Unreal commandlet. It gathers all of the implemented subclasses and runs them to gather and export the data. This process is run for every single build we make using continuous integration via BuildKite. We download a pre-built editor, run the commandlet, upload the output to a storage bucket, and then validate that everything was processed correctly. If anything goes wrong here, missing assets or bad configurations, we find out as soon as it happens, and we get notified via Slack. This is an example of what the web export data looks like. Very simple, clear JSON. It's just a list of packages, and each package contains items that reflect the data gathered by the web export collectors. And here's what that data looks like when displayed in the item inspector in our Game Tools website. We're looking at some assets from Season 4 of the finals. Since we export the Unreal icons in the web export, we can see what the player will see when browsing the customization menu in-game. It's a case where content in Unreal is our single source of truth. We can also change various properties here, which allow artists to own the asset and determine whether the art is approved or needs revisions. This view is filterable with lots of options to narrow down the search, show only the items of interest. And links with other assets, such as outfits or bundles, are also displayed here, and you can easily navigate between them. And the item inspector also has links using Skyhook to open the assets directly in Unreal from the web browser. It's very connected. Nice. So the cool thing about the Game Tools website is that it's all built on top of a simple API that we call the metadata service. Any authenticated developer can use this API, and it is well documented via Redoc, so developers can quickly understand how the requests and responses work for each endpoint. Whenever the API code is updated or the endpoints change, there's a simple command to regenerate all the documentation. We could fully automate this, but we prefer sanity checking any generated code. We also have testable and executable REST API docs via Swagger that work in the same way. This means it's very easy for anyone on our development team to take advantage of these services. So with this metadata service API as our source of truth, there's a lot we can do. Since this is available for all of our developers, it can be used to drive various services for different teams. We have web-based views of game data in the Game Tools website, which I'll show an example of in a moment, and Embark's Data Intel team, which uses the same services to build reports that provide insights to the wider team. And for Unreal developers, such as level designers, we can view this data directly inside Unreal via the telemetry viewer tool. So, still on the Game Tools website, any Embark developer can examine heat maps of our games using data from internal playtests and live games. Here, for example, we're looking at the Monaco map in the finals, and we can see a heat map of the player movement across various game modes. And different types of data can be visualized: movement, player combat, performance metrics, to name but a few. This simple and quick overview gives developers the ability to understand how players are experiencing the game and what changes could potentially be made to improve the map's gameplay or performance. And of course, since it's all coming from the same API, the data that drives the heat map view in the Game Tools website can be viewed in 3D in Unreal. This allows level designers to get clearer and more specific views in the context of the level itself, where they can navigate around using familiar controls and filter, time slice data to get a clearer view of the areas they are interested in. For example, looking at the Monaco map here, we are filtering down just to the heavy player's movement. And you'll notice that they don't get up on top of that crane very often. But if we take a look at the light players instead, we can see that the crane is a very popular location, most likely for sniping. Another example is looking at the damage dealt. Even though it's a popular place for light players, the crane doesn't actually provide that much of an advantage in terms of damage. So it's interesting to compare. So let us get a bit experimental and think about how tools and APIs can help us become more efficient. So remember how we've been talking about sources of truth? Consider that large language models, or LLMs, can be great for summarizing and distilling large amounts of information. You can take your documentation, your planning data, exported game data and feedback, input all of this to an LLM, and then ask it for analysis. The LLM can help in producing tailored outputs depending on the target audience. Players, developers, or executives are all interested in different things here. So let's take a look at some practical examples. Ashwathi Revi, one of our AI's researchers at Embark, gave this example at the Everything Procedural conference earlier this year. Her talk was Creative Support for Game Writing, How LLMs Can Complement Human Creativity. The idea is to have an agent which simulates many playthroughs in the game, encountering your content in different situations. This could be an AI agent or a simple programmatical one, as long as it outputs structured data that the LLM can read. A language model then reviews each instance of that content as if it were the player, seeing it with fresh eyes. This lets us catch tone issues, inconsistencies, or contradictions. It's kind of like a narrative QA, where the LLM here helps you understand how your writing actually comes across to the player. This can be important in games where many combinations of content can lead to an explosion of possible scenarios that become really expensive to test manually. Another example is an LLM-powered log explorer. It does some pre-processing on the logs, and then uses an LLM to read and interpret that data. The result is a kind of session summary told from the player's perspective, not as analytics, but as a story. And that gives writers, designers, and researchers a way to actually see the player's narrative experience. It tries to pull out emergent narratives, like a player trying to sneak through an area, but getting caught and improvising their way out, or players forming social moments through unexpected group dynamics, inventing intrinsic goals, like collecting every frying pan in the level, even though there's no mechanical reason to do that. It can also show how and when narrative beats were encountered and unlocked, and how players' intentions evolved over the session, and what strategies they use. The LLM's role here is not to generate content for the player, but to help us, as game developers, understand the story that the player experienced. And this is obviously just scratching the surface of things we could do with LLMs. So, what can we take away from this? I think there are 4 fundamental elements here. The first is that we should create well-thought-out, easy-to-use services and APIs that can grow over time to become standardized and well understood. Then, we should make this data available to all of our developers, encourage questions and feedback, and make those services really solid and stable. And anything that you export or import should be automated, so people don't have to worry about it, and write tests to make sure that everything is always functional here. And finally, everything must be well documented, and use the power of sharing and cross-linking between apps to make sure that information doesn't get lost or duplicated. You should fight for a single source of truth wherever possible. So, game development is all about iteration and refinement. You can achieve this by building simple, small, but useful tools and services, and making it easy to join them all together. At Embark, we've always made trust a main pillar of our company. By having trust in your development team and giving them autonomy, you enable developers to refine their craft and help each other to create great games. And that's what I mean when I say that the whole is greater than the sum of its parts. So, yeah, thanks for listening.